Pandya sir, can you switch on your this camera? Okay, now you are visible.
Fine.
Okay, dear participant, today is our 5th day of the FDP, and this is the 9th session. Good evening to all of you, as well as to speaker, Mr. Pandya. Before starting and handovering the session to the Mr. Pandya, I would like to introduce first Mr. Pandya. Mr. Kartavya Pandya right now is a head in the supply chain management in Jyoti CNC Automatic Automation Limited. He has 19 years experience in machine tool industries. His expertise areas are production planning and scheduling, MRP, purchasing and cost analysis, ERP implementation and process integration, capacity evaluation and inventory management, on time in full performance improvement, throughout optimization and lean practices. His key contributions like this: lead multiple digital PPC and ERP driven process integration initiatives taken by him. Successfully, he has implemented lean supply chain and operational excellence programs. His focus area is driving smart, data-driven and lean manufacturing system aligned with the Industry 4.0. With this brief introduction, now I would like to hand over the session to Mr. Kartavya Pandya. Pandya sir, it is over to you. Thank you very much.
Thank you. Thank you very much, sir. I am going to share my presentation. Are you able to see my screen?
Yes, sir.
Fine. Just a minute. Now it's full screen?
Yes.
Fine. Good evening, everyone. First of all, thank you. Thank you very much for giving me such a great opportunity to share my experience. Today, I'm going to share some my experience around smart production planning, or we can say digital PPC. When I say smart PPC, I want you to think how the industry is moving from traditional way of planning to data driven or intelligent decision making. In a previous days, it's a manual processing, and nowadays it's a data or system driven approach. During a session, we'll see what are the different challenges in the past and what are the new technologies we are using in India as well as at Jyoti CNC. Let me move back to second slide. Next. Fine. Why FTB on smart production planning? Faculty development program mainly aims to, it's a knowledge bridge between industrial practices and academics. Industry 4.0 is reshaping the manufacturing, especially production planning and control. For mechanical engineering, we have to understand digital manufacturing trends, explore the research opportunities in smart PPC, prepare students for a Industries 4.0 ready careers. This is a broader outline, or what we can say. This is what we are aiming for today's session. If we consider for today's session, below are the session objective. Provide an overview of a smart production planning in Industries 4.0, practical insight from machine tool industries, presents Jyoti CNC's case study, and highlights around research direction and academics opportunities for faculties. Let us start with smart production planning. Uh, Here I have written some text, but let me give you one example. Smart production planning is nothing but a Google map for a factory. Uh, while driving, we are using a Google Maps to get the direction. In factories, smart production planning systems are Google Maps for them. Smart production planning takes a live data, checks condition, predicts delay, reroute the production to meet the deadlines. Smart production planning includes different tools or techniques like IoTs, AIs, cloud-driven analytics. These all tools make entire system agile and predictive. Let us go to the basic. Just everybody have a information around what is the industries for. No need to explain much more, but it's the fourth industrial revolution. Just diagram shows us different tools and techniques: IoT, cyber securities, virtual reality, big data, autonomous robots, adaptive manufacturing, simulation, system integration, and cloud computing. Think of a smartphone. It is connected to a cloud, apps, GPS, and sensors. Similarly, a smart factory connects with CNC machines, ERP, and IoT device. Industries 4.0 aims to physical manufacturing with digital intelligence. Let us see something in a detail. The image you are showing, the image in front of you shows us so many things. It's a evolutionary history of industrialization and machine tools. Here we can see Industries 1.0, Industries 2.0, Industries 3.0, and 4.0. Late 18th century, it's a first revolution. First industrial revolution is introduction to mechanical production facilities and supported by water and steam power. Second industrial revolution is a mass production with the help of electrical power. Third revolution is combining IT and electronics allows further automation and production processes. And nowadays, fourth industrial revolution, connected enterprise, connected production facilities, and internet on things. As industries grow, machine tools also grows. While industries 1.0, there were a machine tool 1.0. Machines are manually driven, manually operated. Next phase is machine tool 2.0. Now machines are electronically driven and numerical controlled. Then we get machine tool 3.0. It's a CNC machine manufacturing around 1980. And nowadays we have a machine tools 4.0, cyber physical machine tools, cloud based solutions. In the parallel, industries, machines, and operator skills are also changed. In a single slide, we can see around 250 years of progress. In a 250 years of progress, we can move from industries 1.0 or manual operation to system driven automations or automatics machine controlled output. Let us move to basics of production planning and control. Production planning and control refers to two separate production stages. It's a production planning and production control. It's the process of managing resources, manpower, schedules, and other aspects of producing a goods. Production planning and control is implemented by business to further strengthen their production processes and prevent the setbacks from the affecting their normal operations. Production planning and control mainly divided into these 8 steps that we can see on the screen: planning, routing, scheduling, loading, dispatching, expediting, inspection, and correction. Planning decides what to produce, when, and how. And control means it's happening as per plan or not. Ultimately, production planning and control keeps factory efficient. Production planning and controls drive the entire system. These 8 steps are nothing but theories or manually we are learning in a college days.
Excuse me, sir. Pandya, sir.
Yes, Z.
Sorry to interrupt you.
Yeah.
Some participant writing the message that screen is not visible. So please just see your PPT is not visible. So
Are you able
share
to
it.
see?
Just share it again.
Let me try. Just a minute. Huh?
Okay. Is it visible now? Participant, just put the message in chat box. Okay. Now it is visible, sir. Please continue.
Okay, fine. Thank you. So these are the 8 steps of production. It's a basics of production planning and control. Just like a industrial revolution, let us see the evolution in a PPC. Before PPC, PPC means printed circuit board. It is a 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 printed circuit board. It Before 1960s, normally planning are done on the basis of EOQ, economic order quantity. Before 1960, people are doing planning manually or paper pen basis. In 1960, MRPs came up. It's a first trigger that uses computer for a planning. Later on, in 1980s, MRP integrated with different enterprise resource planning. So it's converted into a MRP, converted into a ERP. In 1980s, MRP to ERP integrated a wider range of business processes beyond just manufacturing becoming like HR, finance, production. Every department of an enterprise is integrated. Later on in 2000, it's APS, Advanced Planning and Scheduling. Till the MRP, till the MRP, it's a only material and resources. Now it's a advanced optimization. It's a advanced scheduling. It's a specialized scheduling, we can say. And nowadays, it's a digital PPC, where IoT and AI or digital twin creates the factory. So, in the past, people are taking manual decisions, and nowadays, it's a intelligent planning via empowering different decisions to cloud or analysis driven approach. Still, further in a detail of PPC or older PPC system, here you can see in an image, there are different three stages are there. One part is strategic, second is tactical, and fourth is operational. Strategic means what? Where the big decisions are made, balancing demand and capacity. Tactical is medium term horizon, where the material and capacity planning are done. And third is operational planning. It's a day to day execution. It's a shop floor control. Are you able to get na? Strategic, tacticals, and operational. Strategic always considered as sales and operation planning, S&OP, and master the production schedules. Uh, Considering in Jyoti's scenario, if I'm thinking around 2020's production schedule, it's a strategic or long-term action. It's always driven by marketing or sales. It's a long-term actions that gives us rough cut capacity calculations or demand management. Once S&OP planning get it approved, it converts into a master production schedule. It might be in a months or in a years. Master production schedules later on converted into a material requirement plan and evaluate the capacity assessment of a current scenario. Maybe it's a 3 months or 6 months horizon span, and later on, material requirement plan converts into a production orders. Maybe a 3 months or for a 1 month or a day-to-day operations. It's nothing but a day-to-day shop floor controls. Every three parts are differently connected with each other to get the accuracy level. Blue lines are showing us a feedback or closed loop mechanism to improve further. Strategic always, where do we want to go? That answers we will get from strategic. From tacticals, what resources we need for now. And operations means it's a day-to-day execution. Strategic always provide us a direction. Tacticals provide us for a preparation, and operational provide us for execution. This is a traditional approach of a PPC. And nowadays, what we call smart PPC. Just check for the image, go through the image. Bottom of the image, we can see the connected production systems. It's an entire factory. We can consider machine, robots, sensors, and supplier. Supplier for information, delivery schedules, open orders, contract, stock at vendor, everything is connected through IoT and cloud. This is a foundation of PPC system. Now, next part is a PPC in a connected system. Now we have a data from a multiple systems as every system is connected. Shop floor, supplier, logistic. Now we have each dashboards. Now, as a planner, individuals are not guessing anything. Instead of guessing, they are actively monitoring. With the help of data, they are analyzing the information. This makes a PPC operation transparent. Everybody can see what is happening, what actual progress is ongoing. Next layer is transparent. Transparent layer. The system doesn't just collect a data, it analyzes the same. Big data analysis tools examines factors and identifies the causes of issues like machine vibration or non-quality of our raw materials or any issue created by operator while doing the setting. Everything we can analyze. Top of the image, we have a intelligent. Where AI comes into the picture. System investigate the root cause, uses predictive models and ask, should we change the parameter or supplier? So now smart PPC is connected, machine and system, sends the live data, connected, transparent. Transparent means analytics show why the things happens, and intelligence. AI make a suggestion or decision makings. In a older days, PPC is just a firefighting department. And now it's a proactive and intelligent function. So smart PPC is a humans with AI, humans and AI working together. So we have seen standard PPC or traditional way of a PPC thinking and smart PPC thinking. Now here we can see some core technologies that transfer PPC into a Industries 4.0 or smart PPC. IoT, cloud computing, artificial intelligence, AI, big data analytics, and cybersecurities. IoT, connecting machine sensors and device to collect and exchange the real-time data. In a planning, real-time data is very essential. Second is a cloud computing, provides scalable computing resources and data storage for analytical processing. Third is AI, enabling predictive maintenance, quality control, and autonomous decision making. Fourth is big data analytics, processing vast amount of data to uncover insights and optimize the processes. And fifth is cybersecurities, protecting interconnected system for digital threats and ensuring data integrity. So these five are the core technology of a Industries 4.0. In continuation of this, we need a integration of these four to build a smart PPC. Without integration of these four technologies, we cannot go for a smart production planning and control. Furthermore, smart production planning and control converts APS, IoT integration, AI-driven demand forecasting, auto MRP linked, and digital twin for simulation and scenario planning. We will see one by one in a detail. For a smart PPC, let us start with APS, advanced planning and scheduling. As we see earlier in that industry evolution screen or evolution of a PPC, from 2000 we have advanced planning and scheduling. That is one of the or beginning part of a industries 4.0. Advanced planning and scheduling is a sophisticated approach that integrates software tools, algorithm to optimally allocate manufacturing resources, synchronize production scheduling, and adapt dynamically to change demand, enabling manufacturer to improve the efficiency, reduce the lead times, and increase the customer satisfaction. APS is nothing but a engine of a smart PPC. It's a basically engine. Without APS, we cannot do planning. It's a first step. Traditional planning look like MRP and ERP. They are good to tell us what material we need, when and how much. But MRP and ERP cannot handle sudden changes that comes up. APS goes beyond that and takes the real-time data from machines, material, and demand, and then build the most efficient scheduling. It's a just like a airline scheduling. APS gives us a different benefits. APS are powerful and gives us a different benefits like agility, efficiency, customer satisfaction, and cost saving. In a market, different softwares are available for advanced planning and scheduling. Now, let us come to IoT. Like APS is an engine of a PPC, IoT is a eyes and ear of a factory for any factory. Just like a smartwatch, it tracks us. It tracks our heartbeat, sleep, steps via sensors. Same like in a factories, IoTs or sensors used to record the temperature, vibration, spindle speed, tool wear, and energy used. Every small detail to track or monitor or record. IoT can say us when the tool life is going to end or spindle vibrations are abnormal. It gives us live tracking of any machines. IoT help us to predict maintenance that gives us a transparency, efficiency, faster decision making, and to build the customer confidence. For IoT also, some of the softwares are mentioned here. So finally, IoT makes live tracking for a factory for visibility, predictability, and efficiency. Later on, we will discuss how Jyoti is connected with this. Now, same in continuation of that already we have discussed the real-time data analytics, performance optimization, and predictive maintenance. Performance optimizations via real-time data analytics, monitoring machine utilization efficiency, identifying bottlenecks and area of improvements, adjusting parameter for optimal output and energy, reducing waste and material consumption. In a predictive maintenance, detecting anomalies in a machine's behavior before failure, scheduling maintenance proactively, not reactively, reducing unscheduled downtime and production losses, optimizing spare part inventory management. Furthermore, AI driven forecasting and auto MRP. Like EPS and IoT, AI is a brain for smart PPC. Normally, factory generates thousands of signals every single minutes, but humans cannot process it. So, lots of data with the help of AI, we can make the decision. AI forecasting is about using artificial intelligence to predict future demand, production need, and supply trends. Traditional forecasting methods rely on historic average, but today's demand changes rapidly due to customer preference, global supply chain, and market disruption. AI goes deeper. It looks like past data, current trends, seasonality, even external factors like weather and economical signals to give the more accurate forecast. Now, this AI driven forecasting integrated with auto MRP so that we can get more benefits on higher level of accuracy, faster planning, agile output, less stockouts and overstocking, and better cost control. Some of the softwares are mentioned here. So finally, we can conclude that in terms of AI forecasting and auto MRP together act like a navigator for the planner, navigation system for the planners. Ultimately, this makes a production faster, leaner, and more reliable. Now, last one is a digital twin simulation. As a concept, it's just look like a virtual copy of a physical system. Existing physical setup, we have to digitally convert same system. As a concept, if we can talk, a digital twin simulation is a dynamic virtual replica of a physical object system or processes that uses real-time data and advanced technology to mirror, analyze, and optimize its world counterpart continuously. We can do simulations. We can predict the situations. We can analyze the data. We can analyze futuristic system after 15 days or 10 days. What will be the production load, or which part at what production stage, that we can visualize. Considering we are manufacturing X number of parts and now we want to do 2x, then what will be the bottleneck areas? Digital twin gives us a different benefits. Via digital twin, we will have a zero firefighting, lower cost, faster production development, and continuous improvement. Digital twin is nothing but a crystal ball. Now, let us move to the real world scenario. Uh, Let me something discuss with you about the Jyoti. In the past, what kind of problems we are facing or what challenges we have. At a Jyoti, we have a large complexity. We have more than 5 lakhs SKU, approximate 200 finished goods. They are having a multiple parts. We have a total integrated system. We have a foundry, sheet metal, paint shop, machine shop, assembly and sub-assemblies. We have all varieties of manufacturing shops or plants. We have a different product mix. We are manufacturing, turning, milling, HMC, 5-axis machines. We have a large portfolio. So product mix is one of the challenge for us. Different shop with bigger basket of portfolio. And now we have to align the capacity. Ideally with the sale forecasting. Even we need agility in terms of demand shifting, urgent orders, or engineering change management. Integration of ECM with BOM and deliveries or OTIF supply. Ultimately, what we need to focus with this complexity or with these critical areas, we have to ensure on time in full, higher utilization to reduce the bottlenecks, faster response, and at lower cost. To ensure on time in full or go for a smart PPC at Jyoti, we are using three systems. To convert routine scenario or standard planning to smart planning, we are using three systems. We are using SAP, we are using Phoenix, and our own Industries 4.0 tool, 7sense. We are also offering same tool to our customer. SAP is a standard ERP software solutions. Phoenix is our in-house manufactured ERP solution, ERP or workflow automation solution. SAP is our backend, while Phoenix is our front-end solution to do system entries. And 7sense is a highly automated machine capable of processing the most sophisticated operations in the industries. We will see in further in a detail for a 7sense. So for a smart production planning, we are using three different tools. In between, we have explored so many things like Plan Simulator from Siemens, another tools like Simulate. We will discuss. Let us see these three different software, how we are utilizing or what all are aspects. SAP is a commercial ERP suite. Phoenix is an in-house developed ERP. And Industries 7sense is the Industries 4.0 smart automation framework. From SAP, mainly it's our backend, and from SAP, we are taking material requirement plan, while other business processes like sales, HR, finance is integrated via Phoenix. And for real-time shop floor automations or data, machine health, tool lives, and productivity monitoring, we have a 7sense. SAP used for backend supply chain, procurement, and quality. Phoenix is as I already discussed, is a front end for everyone for workflow management. And 7sense is used for the shop floor, CNC machine monitoring, and smart PPC. In SAP, we can do somewhat customizations or moderate, we can say. Due to our in-house ERP, Phoenix is highly customized, tailor-made. It's a Jyoti's need-based product. Same in case of 7sense, we have two different scenarios. Some modules are standard and some of the solutions are customized as per customer's requirement or our internal requirement. SAP gives us robust planning and quality compliances. Phoenix, real-time data entries, data analytics, and scheduling. We can say some of the escalation metrics or triggers or alerts generated via Phoenix. And 7sense is a reduce the manual tasks, predictive maintenance, and productivity insights. SAP ERP, Phoenix is the business process automation, and Industry 4.0 integrations via 7sense. Use case at Jyotis. Integrations and deployments. So basically for a smart PPC, we have three systems in place. Gradually we have initiated around 2000. From 2004 we are using SAP. From 2015 we are using Phoenix. And from 2019 we are using 7sense. We are not saying we are at par in terms of Industry 4.0, but we are on the way of Industry 4.0. Still, there are so many opportunities that we will discuss. We will conclude further. So, SAP, Phoenix, and 7sense. We have a dedicated teams for development of Phoenix and 7sense. Almost more than 50 people, engineers are working on it. Every day, they are improving our products. Let's see further. This is one of the screenshot how we are tracking real-time data or punching this real-time data into a system. This is integrated with SAP or a ERP. This is just a screenshot of a screen of a Phoenix shop floor system. One production order number is there. Routing or operations are there. Batch quantity is there. Operator from Phoenix, they are doing real-time punching to ensure quality of a scheduling. It's nothing but just a front end of a individuals to punch the data, to pass the information to the planning. Now, let us see around the 7sense by the Jyoti CNC. It's an intelligent machine management. We can say virtual machine screen for the live status. Smart navigation reduce human error. Predictive reports for the data-driven decision makings. It's a completely Industry 4.0 driven approach. It's directly connected with any machines, or we are selling every machines with 7sense, or depending upon customer, they need this option or not, but it's a part of machine integration. Real-time productivity monitoring via 7sense, live tracking of production and machine. This data directly comes from machine monitoring or machine PLC. daily output visualization for agile planning. We can also monitor or review OEE reports from the 7 Sense. Tool and health optimization, tool life tracking to prevent the breakdowns. Machine health alerts enables the proactive maintenance. Centralized cockpit dashboards, quick overview of tasks, alerts, and competition stage. Completion stage. Streamlines planner focus from data gathering to strategies. Big data integration, cloud integration for scalable analytics, supports forecasting, inventory control, and market intelligence. So, via 7 Sense, we are one step ahead from the others to get the to build the accuracy or quality of a smart planning. Now let us talk about machine tool interfaces. Via smart PPC, what the benefits we will get or what the benefits we will have. Reduce the lead time and increase the resource utilization. Using smart PPC, better on-time delivery performance, as already I have discussed. Minimize downtime and extended equipment life through predictive maintenance. Improve the decision making through data-driven insight. Greater production update and energy optimization. And enhance the collaboration and improve the safety. We have seen Jyoti. Now it's a Indian machine tool industries. What benefits we can get from smart PPC? Typically, for academics, what benefits or contribution? We can do R&D, skill development, technology transfer, innovation hubs, ecosystem development, and policy research support that we can build. Same challenges faced by the machine tool industries for digital transformation. It's a high capital cost, skill gaps with AI and robotics, people are using outdated tools and integration, poor internet and power supply, limited digital factory adaptation, cybersecurity and data privacy. So these all are the challenges. High capital, skill gap, legacy in a infrastructure, digital infrastructure, and cybersecurity issues. Same against these challenges where academics can play a role. To build a multidisciplinary skill programs, to conduct the collaborative R&D that gives us higher edge for a lower the capital cost. Design industries relevant curriculum and continuous upskilling initiatives to bridge the workforce gap or skill set. Facilitates technology transfer, incubation centers, and support startups to deploy the smart tool tech. Provides policy advice and promotes digital legacy. cybersecurity awareness, and infrastructure growth. Academics can lead cybersecurity training and cyber physical system security research specifics to industry's trend, where academics can help not only Jyoti or India, some of the other machine tool manufacturer already adopted smart production system like Tata Motors using IoT, and via using IoT they have reduced the downtime by 15%. Godrej utilized AI driven quality controls and improved 10% reduction in defects. Same in case of Bharat Forge, deployed a cloud-based production monitoring system, allowing a real-time visibility into a operation and improved a production scheduling across the multiple plants. Let us go for a conclusion or key takeaways. Smart production planning equals to future of manufacturing. Industries 4.0, IoT, AI, cloud, digital twin transfers PPC into a dynamic data-driven system. Indian machine tool industries needs transfer faster digital adaptation to stay globally competitive. At Jyoti shows how Industries 4.0 adaptation improves utilization, deliveries, and efficiency. Still, we are going further, deeper into a Industries 4.0. We are on the way, or some of the projects are going on for a dark factory, for a FMS, for a Industries 4.0. So we are not at 100%, but we are on the way. We are improving. We are improving every day. And we have concluded role of the academics, faculties, research, and teaching integration can prepare a future engineers for industries 4.0. What actions we can take further? For industries, accelerate the adoption of smart production planning tools, focus on agility, utilization, and predictive systems. At academics, integrate the smart PPC and Industries 4.0 modules in a curriculum, promotes faculties and students research in IoT, AI forecasting, and digital twin, build the low-cost labs to build the prototypes for training and experiment. For faculty participation, act as a knowledge bridge between theory and industry practice, guide the students towards Industries 4.0, ready skills and projects, collaborate with the industries on joint research and consultancy. Just sharing my experience in a last month, I have I had two different students from IITs, and we were working on a plant simulator from a Siemens. We have analyzed data, or we have converted a big data into a via software. We have converted into a some futuristic or simulations based output. We can predict, we can analyze if product mix going to change, then what will be the resource gap, what will be the we have analyzed for what is the storage required. at what point of time at shop floor, what WIP we can see. So we can participate, we can take such projects, and we can demonstrate our strength, or we have to learn, we have to start thinking around the software utilization, we have to upgrade our skills. We have different challenges or opportunities available with us. Fine. So that's it from my side. Thank you. Thank you for listening.
Thank you very much, Pandya sir. Now we are opening the session for question answers.
Okay.
So participant, if you have any questions, then you can write into the chat box or you can raise your hand. Pandya sir, hello.
Yes, sir.
You can open the chat box. Few
Okay.
participants ask the questions. There they
Okay.
have written the questions.
Okay.
Uh, Pandya sir, can I read for you?
Almost fine.
First question is, can you brief digital twin system?
It's a nothing but a replica of a physical system. It's a virtual scenario where we can simulate. Considering we have a machine shop, in a machine shop we have a 250 machines. That 250 machines are integrated into a one single platform. It's a just a digital copy of a physical shop floor. It's a virtual world. We can simulate the things. Um, we can integrate the material flow. We can integrate material handling equipments. We can build the bill of material. We can integrate the bill of material. We can integrate the routings. We can visualize or simulate before taking an actual decision or going for a any further, might be a capex or future expansion. Consider we are making 500 machines per month and we are thinking of 1000 machines per month. Then this digital twin systems can help us to build or visualize what capex or what add-on resources are required. It's nothing but a replica. We can predict or visualize, we can build, we can add on. Considering we have 250 machines on a floor, now let us think of 300 machines we have. Then what will be the scenario? So it's a kind of a simulator, or we can take a decisions from a system to get the data, or existing system how it will react or perform on a later on stages, that we can visualize. For new product development also this will help us a lot.
Okay, thank you. And just I am giving you the small information to participant. Tomorrow our first session is exclusively on digital twin system in manufacturing or micro manufacturing. Okay, sir. Next question is, are there any free or open source ERP software for small scale industry? If so, what are they?
ERP solutions are available. But typically, for a small scale, um, like Odoo is also providing a free, but they are not giving actually a free. But s- not free, but at a lower cost. Some of the options are available at a cheaper rate. Uh, Most of the around Baroda, typically, one of the solutions is Timeline ERP. UK based company is there. They are providing such a solutions. One of the okay, I am in touch with some of the person, or I am the participate. I am in a participation of some of the software development firms. If you need a help, I can provide you some contact numbers or resources from Ahmedabad also. Uh, Recently, one of the good friend already developed a smart PPC as a solution, and I'm a part of that. So, if you need, I can help you. They are providing cheaper solutions with, but they are fully. They have recently they have completed capacity evaluations and scheduling. Now they are building us CRMs.
Okay, thank you, sir. Next question is, sir, can you please give us some insight of working of Jyoti CNC towards providing Industry 4.0 solution to Indian industries?
Yes, that is a 7 cents. It's a complete package. It's a full line. Uh, uh, we have some of the customer. Uh, they are operating from overseas, from France or from US. There are some certain machines we have in a production. Uh, Consider it's a new product development. We have a bunch of machines in a new product development for their requirement. Now we have builder machines. We have integrated it with 7 sense, and remotely they are visualizing their machines progress development. Uh, in specific, one of the specific requirement, we need continuous 30 days trial, non-stop 30 days trial. So via 7 sense, they can visualize machine is down or not, spindle is performing well or not. Everything is connected. Is there any vibration or not? Is there we are getting any chattering mark on a component or not? Everything via 7 sense or such a software we can analyze or predict. So we are on the way in terms of industries 4.0. 7 sense for any machines. It's a good options to monitor, predict. We are every day we are using it for our internal OE measurement. It's used for the uh, predictive maintenance. So 7 sense, okay. You can go through Jyoti's site, or some of the videos are available for a 7 sense that will help you to understand the exact scenario, how it works.
So next question is, which kind of skill set you expect from future engineers?
Uh, First is adaptability, and second is that curiosity. What next? Once this is done, what is next? Now, what I have to do? That will make a difference for individuals.
Okay, is there any further question from participant? Okay, if there is no question, then we are going to end of this session. Thank you very much, Pandya sir, and we will look forward in for future. Thank you very much.
Thank you, sir. Thank you, participant. Thank you.